Hello and welcome. This is going to be our lecture video for the week of October 26th. Get your notes out and let's go ahead and get started with a problem that comes to us from our last lecture. Write an equation in vertex form to describe this graph. Go ahead, just look at it, see if you can write it into your own notes. Okay, so what I'm going to do is I'm going to put a point at the vertex and label it as -3, -3, and then label those numbers as h and k. Those I'm going to plug right into this formula, y equals a times x minus h squared plus k. That is vertex form. The only thing we're missing now is a. Well, a trick, if you can see all of the grid lines, just go over one. Typically, we would go over one, up one, but go over one and see where the line is now ending up. So we went down one. And if that hits at a nice ordered pair, this is your a value. So that is the a value. Because that is what multiplied the value of +1 to get this new change from the vertex. So we plug that all in and we get y equals, I don't have to write the whole -1, I'll just write the negative. X minus h, but it's minus a -3, so minus a negative becomes a +3 squared, and then plus a -3, I can just rewrite that as -3. And there is our equation right there. This equation, when graphed, will exactly recreate that red line. All right, but what if we can't see the grid lines? Then we can't use that trick to find a, so we've got to use another point that the graph clearly goes through. Here we've got one labeled. So this will still give us our h and our k value. Then we'll use this to find a. So use to find a. If you need to, pause the video and sketch this graph real quick. All right, so again, I'll start with vertex form. Y equals a times x minus h squared plus k. I'll only add the h and the k values because we know those. It's a different color. Y equals a times x minus -8 becomes +8 squared plus 4. All right, now this I can borrow as an x and a y value. We know that the equation has to be true at this point, so if I plug this in for a y and an x, I'll have every variable except for the missing a, and then I can find the a that makes this true. So now y will be replaced with a -2 equals a times -6 plus 8 squared plus 4. And now solve for a, and it's not that many steps. I might start by subtracting 4 from both sides and also combining what's inside the parentheses. -6 equals a times 2 squared. -6 equals 2 squared becomes a 4, so I'll rewrite this as 4a. Divide both sides by 4, and I get -3/2 equals a when I simplify that fraction. All right, put that all together into one equation, and we get y equals -3/2 times x, going back up here, plus 8 squared plus 4. So there's your equation with a, h, and k filled in. This equation will exactly recreate this red line. Our goal for today is to be able to convert any quadratic into standard form. Why we're doing this, it's the most simplified form and will be useful once we get to the quadratic formula. Although I think vertex form is maybe more useful because it has those parentheses. It's not considered to be the most simplified. In quadratic formula, it relies on us knowing what the a, b, and c values are from standard form. So here is standard form. Copy it down. The one thing to kind of pay attention to here is that the c value, the constant, that's going to be your y-intercept. That's the one feature of the graph that you get for free from standard form. All right, also a is the same a. All right, because of how the algebra works out, the a in vertex form will not change at all. It will remain the same value. All right, it's h and k that combine in unique ways to form the b and the c values. Also, a is involved in finding h and k. Okay, what are the values of a, b, and c in the following? So these are both already in standard form. Let's just write down what A, B, and C are for each of these. All right, A is the coefficient on the x squared term, so 3. B is the coefficient on the linear term, so 4. And C is the constant. I see a -2, so the constant is that whole thing, the -2. Let's try it in this next one. This next one only has 2 terms, so one of these gets skipped. Which one is it? If I see just a negative, the A value is going to be a -1. If I don't see an x by itself, that means the B value is 0, and that's causing that linear term to disappear. And then the constant at the end is a 5. All right, what is range? Your worksheet for today asks about range, so we better have a good definition of that. It is the possible outputs / y values of a function. We talked about this before with absolute values because absolute value graphs also have a restriction on the range. Not write down function all the way. There we go. So the range for a parabola, if A is positive, so we'll just say greater than 0, and that means positive. The range is y must be greater than or equal to the k value. If A is negative, so if A is less than 0, the range is y must be less than or equal to k. It's impossible to output a y value greater than your vertex in this scenario because of the way that the parabola is opening. All right, let's try that on a real problem. Here we've got a parabola. What is the range and what is the axis of symmetry of this parabola? So the highest point it goes to is right here at 4, 2. This is the highest y value. So we need to express that in our range with an inequality. The range for this parabola is going to be that y must be less than or equal to 2. All right, the axis of symmetry is a vertical line that goes through this point here. Maybe we'll make it a dotted line. How do I write the equation for a vertical line? Well, it has to be an x equals equation. So the axis of symmetry here is going to be x equals 4. It's always x equals the h value. Make that clear, that's an h. All right. So here we've got an equation in vertex form. We're being asked to convert to standard form and find the y-intercept. Here we're practicing another technique we learned in the last lecture, which is foiling. But now we've got an a value. I don't think we saw that last time. So y equals 2 times x plus 3 squared. Whenever I have something squared, that means take the base and multiply it by itself that many number of times. So x plus 3 times x plus 3 plus 4. All right, not done with the parentheses. Got to get rid of them by foiling. So I've got to multiply my first, outside, inside, and last terms. When I do that, this 2 is still waiting to be distributed to all of that. So keep it in a set of parentheses for a second. 2 times x squared plus 3x plus 3x plus 9, and then a plus 4 still at the end here. Let's combine like terms. Y equals 2 times x squared plus 6x plus 9 plus 4. And now we can distribute in this 2 and finally get rid of all of the parentheses. So that doubles the coefficient on everything. Now we've got y equals 2x squared plus 12x plus 18. Still keep this plus 4 at the end, because now it has a like term that it can combine with. And when we do that, we get y equals 2x squared plus 12x plus 22. Now the problem asked us specifically, what is the y-intercept? The y-intercept is 22. it will cross the y-axis at 0, 22. All right, so we're getting pretty good at going from vertex form to standard form. There is a way to go back and relies on something called completing the square. Here I've just got a preview of this. This will be in our next lecture. But if I want to rewrite this piece here as something squared, I can do that, but I have to add in some sort of constant, because when I FOIL this, you always end up multiplying that last number by itself. So I add in a 9, which is half of this b value squared. And that way, this side here can now be exactly represented as x plus 3 squared. But I can't just add in a 9 to one side. That's not a balanced operation. So hopefully you notice that this -2 turned into a 7 because it also got a 9 added to it. And as long as I add a 9 to both sides, it stays balanced. Okay, we will go over this more and how to pick the right numbers. But this is an idea of how we can go from standard form back to vertex form. Okay, we'll finish this video with a few more off of your worksheet. So for each of these, we need to graph the function, state the vertex, state the axis of symmetry, rewrite in standard form, state the y-intercept, and state the range. Okay, let's start with the graphing. Easy to do from vertex form because I can see that my vertex, and this is something we have to state, is -2, 2. Don't forget to flip the sign on that h value. Remember, this was x minus h. The h value has to be negative to counteract the negative and give you a positive there. All right, so -2, 2. We can put a point right there. A little better. All right, the a value is 1, so from this vertex we're going to follow our normal parent function pattern of going over 1, up 1, back to the vertex, over 2, up 4, back to the vertex, make it symmetrical. So the pattern is 1, 4, 9. We only needed the 1 and the 4 before we got off the graph. So here is our graph. All right. State the axis of symmetry. We'll abbreviate that AOS. That's going to be x equals -2. Rewrite the equation in standard form. So let's practice doing that. We got y equals x plus 2 squared plus 2. Rewrite that x plus 2 squared as x plus 2 times x plus 2. Keep the plus 2 at the end from that. FOIL this, so first outside, inside, last. And I get y equals x squared plus 2x plus 2x plus 4 plus 2. And now combine like terms, and we're left with the standard form y equals x squared plus 4x plus 6. All right, not super useful, except for it does tell us the y-intercept, and we can see that here in our graph. The y-intercept is equal to 6. You see it right there at the end of this problem. All right, so graph the function, state the vertex, axis of symmetry, standard form, y-intercept. Now for the range, last thing. Oh, click too many buttons. What does it think that I'm doing? I think it was this one get clicked. There we go. For the range, our a value is positive. We can also see that the ends of this parabola are going up. So we know that our y values will never be less than or equal to 2, so they must be greater than or equal to 2. Label that as the range. All right, let's do it all over again with problem number 3, maybe a little bit quicker this time. Let's draw a line to keep all this separate. Okay. Vertex is at 3, 3. Let's put a point there. A value is 1, so from that point I'm going to go out 1 over up 1, out 2 up 4, so 1, 2, 3, 4. Make it symmetrical, connect them up into a parabola. All right, axis of symmetry. The vertical line going right through that vertex would be x equals 3. Let's convert this into standard form by first copying it down. Then expanding that exponent. Then foiling, first outside, inside, last. Get y equals x squared minus 3x plus 9. Negative times negative is a positive. Plus 3. Combine like terms, y equals x squared minus 6x plus 12. There's your standard form. From standard form, we can easily see what the y-intercept is. It is a 12, so the y-intercept equals 12. Make sure that looks like that could be right for this graph, and it does. And the range is that y must be greater than or equal to 3. The y values never go lower than 3 right there at this vertex, and then they start going back up. And I think we did everything for this one. All right, I'll embed a few more for you to practice with, but that's that for this lecture video. Have a good rest of your day.